Okay, so notice that they give you this angle here. It's almost like they're trying to mess you up, right? The first thing I think you want to do is, and they want you to use gravity to be 10 meters per second squared, right? That's a funky thing too. So I think here's that velocity, right? Remember, this is, you're going to break it into components, right? Whoops. Okay, this is 60 degrees. So notice, by the way, that you're going to have more horizontal velocity than you have vertical velocity, right? This hypotenuse is 12 meters per second. So go ahead and break it into components. One of these comes out even. The vertical comes out even, right? And that's because 60 degrees is a special angle. This one ends up being, somewhere between 10 and 11, let me just say. Okay, let me see, did I get that right? Yeah. This one ends up being between 10 and 11. This one is somewhere between 5 and 10. Okay, this one comes out even. It's kind of fun. So the first thing says the maximum height measured from sea level reached by the stone. Well, this is going to be a vertical suvat, right? So you're going to use this velocity here, the vertical velocity, not the 12, but just the vertical part, right? And then go SUVAT, right? The velocity at the top is something, right? The acceleration is, they want you to use this, only you make it negative, right? So negative 10. The initial velocity is going to be this component right here. Okay? And solve for what S is. S isn't very big. Okay? S ends up being between 1 and 5. Okay? And then don't forget, they want to know how far it's going to go up. So there's this height here, right? It's going to go up some distance. And then it's going to go down and strike the sea. They want to know this distance here, from there to there. So once you get this displacement from here to here, add this 30 meters to it, okay? So whenever you get S plus 30 will equal the answer, right? A lot of thinking to do. Not too hard, though, I don't think. Then number 2 says, what is the speed with which the stone hits the sea? I think you're going to do a little T chart, right? You're going to go horizontal, vertical, right? SUVAT. Don't forget, they want you to use negative 10 for the acceleration, right? The initial velocity is going to be this guy. I'll call it Vy, right? And then the horizontal velocity will be this guy. Remember, this is like between 10 and 11. Okay, if it's not, you're probably in radians. Remember, this guy's 0, right? Okay, and then let's see what else. Oh, and we know the displacement is down 30, right? Negative 30. So put that in there, right? Okay. And then what I would do is I would solve for the final velocity using v squared as u squared plus 2as, and on the vertical side, right? Don't forget to make it negative. It's going to be negative something, so it'll come out of this positive. Then I'd use v as u plus at to find the time, right? Time goes across. Actually, you know what? We don't really care where it lands. We just need the speed, right? So once you figure out this final velocity here, I'm just kind of on autopilot, right? You're set. You can find the speed. So you're going to draw a picture of this guy. It's going to be over, down, and the speed will be the hypotenuse of this guy. So it's going to be this squared plus this square root of, right? Vx plus Vy squared. But use your final velocities. Use these guys. Okay. And then the final thing here, B, says in the space below, sketch using the same axes graphs to show how the horizontal and vertical components of the velocity vary with time from the moment it leaves your hand to just before it hits the sea. Notice it's a sketch graph. You do not need to add values. Well, maybe we should add values. I don't know. Okay. So here's what they want you to do. You're going to draw a graph like this. Okay. So this is velocity. This is velocity versus time, right? Okay, or I guess we say time this way, right? Okay, this is positive velocity. This is negative velocity. Okay, you actually know what these velocities are, right? Because you figured it out. You've got a vertical velocity, a horizontal velocity. So keep in mind that they're going to make sure, like notice that the horizontal velocity is bigger, right? The vertical velocity starts out smaller, so make sure you start in the right place. One of them will start here, one of them will start here, or something like that, right? Okay. One of these velocities doesn't change. Okay. One of the velocities decreases, right? one of the velocities is going to decrease. It's going to increase in a negative way, right? Okay, so see if you can draw that picture, okay, of those two velocities. One will be a horizontal line like this. One is going to be a like that, okay? Only they won't be juxtaposed like that. Yeah? Can you do it? It's a good question. I like that question.